Hi everyone. Welcome to Go Classes. So this is standard question session 4 in digital logic. For digital logic we have seen we have had total three sessions we have had so far of standard questions. Okay, so you can watch them on the Go Classes YouTube channel. You can find the playlist digital logic standard question session playlist. Okay, so in that playlist you can find all the standard sessions, all the previous standard sessions you can find. Okay, in this session what we will see some questions of decoder, multiplexer, encoder and demultiplexer. So these concepts, these questions we will solve in this session. Okay, so let's start now. So let's see what are the questions that we will solve. So next template of questions. So what template of questions we will solve in this session? That is okay, so let me just, what template of questions we will solve in this session? We will solve this template. Can you analyze a given combinational circuit? This is the idea. I give you a circuit and you have to analyze that circuit. Okay, am I audible? Is the voice fine? Is the volume fine? Please let me know. Is the volume fine? Okay. So let's see this. Now let's analyze this circuit. This is our first question for today. A circuit is given to you. You have to analyze what is this circuit. What is this circuit? In this circuit, basically this entire circuit, what is this circuit? This is multiplexer, demultiplexer, encoder, decoder. What is this circuit? Hello. So is the volume still low? Hello. I think volume should be fine now. Okay, so let me check. Hello. Is the audio fine? Hello. Now tell me, is the audio fine? Is the audio volume, is everything fine? Please let me know. Hello. So you can use the earphone maybe. Okay. Please use some earphone or headphone, something you can use. So let's start now. So this is our circuit. Let's analyze this circuit. So tell me, what is this circuit? What is the behavior of this circuit? First of all, remember, in this circuit, tell me what is this W0, W1? Like, are they same? First you tell me in this question, okay, this W0, this W1, are they same as this W0, W1? No, this is the decoder. In this circuit, this is the decoder. So this we have, this decoder we have. In this circuit, we have this decoder. This is our decoder. Okay. Next, you can notice that these are not same as this W1, W2. These are inputs. This W1 is an input. This W1 is an input. But remember, this W1 only tells you, this W1 only tells you that this is LSB. This only tells you that this is LSB. This W0. This W0 tells you that this is LSB. Nothing else. This is just W0. Okay, this W0 just tells you LSB and this tells you MSB. Nothing else. Please remember that you can remove them. If you are confusing, you can remove them and you can write 0, 1. Okay, there is no problem. Is this clear? So you can remove them. If you are confusing, you can remove them and you can write 0, 1. But remember, because inside this is a decoder, and inside this, these are just LSB, MSB. They are just telling you LSB, MSB. Okay, inside this circuit. So this is the decoder circuit. You know, this is a decoder circuit. In this decoder circuit, this W0, this tells you that this is LSB. Okay, so this W0 has nothing to do with this W0. This W0 is the input. This is the input. And this W1, this tells you that this is MSB. Okay, so this is the idea. So don't confuse this W0 with this W0. They are different. This is the input and this is just a symbol. This is just a symbol for LSB. Okay, this just tells you that this is LSB. Now let's analyze this circuit. We have to analyze this circuit. So tell me, in this circuit, if you take 0, 0, then what will happen? If you take S1 0 and S2 0, S1 and S0, both you take 0, 0, then what will happen? Remember, the enable signal is 1. Okay, so you can notice this enable is 1, so it means the circuit is working. This enable is 1, it means the decoder is working. The decoder will work. Okay, so if you take both 0, 0, then in that case what will happen? This will become active. This will become 1. Okay, in this situation this will become 1. So you can notice, if you take 0, 0, then in this situation this will become 1 and they will become 0, 0, 0. And they all are connected to AND gate. So this will become 0, 0, 0. And this will become 1. So this will become W0. And finally, you will get F equal to W0. Correct? Yes or no? Very simple. So now let's see. If this is 1 and this is 0, then what will happen? Remember, this is MSB. This S1, this is MSB. And this S0, this is LSB. So if I take S1 S0, this S1 S0, if I take as 0, 1, then what will happen? Then in this situation, this signal will become 1. This output will become 1. This output will become 1. This output will become active. And these outputs are 0, 0, 0. Now what will happen? This is 0, this is 0. This is also 0. And this will become W1. So here F will become W1. Next, if you take 0, 1, like, okay, S1, S0, you are taking them as 1, 0. Now in this situation what will happen? This will become 1 and these will become 0, 0, 0. Okay, in this situation this will become W2 and these are 0, 0, 0. So here F will become W2. And next, finally, if these are 1, 1, if both are 1, 1, S0, S1, both are 1, 1, this S1, S0, both are 1, 1, then what will happen? Then in this situation, this Y3 will become active. This will become active and all other will be 0, 0, 0. Remember, this is decoder. We have already seen in decoder what happens when this data, this input, when this is 1, 1, then in that case your output Y3, this will become active. Okay, and other will be 0. So you can notice this will be 0, this will be 0, this will be 0, this will be W3. So F will be equal to W3. So can anyone tell me what is this circuit? Can anyone tell me this circuit is what? What is happening here? Can anyone tell me what is this circuit? So this is happening. So this is S1. Okay, you can notice you have S1, you have S0. Enable is equal to 1. Enable is fixed. This enable is fixed. This is fixed. This is equal to 1. So the circuit is working. So you can notice that if S1, if you take 0, 0, then your output F, that is equal, if you take 0, 0, if you take 0, 1, if you take 1, 0, if you take 1, 1, then you can notice if you take 0, 0, output F is W0. If you take 0, 1, output F is W1. If you take 1 0, output f is w2, and if you take this, the output f is w3. So tell me, what is this truth table, this functionality? Who has this functionality? Can anyone tell me this? Okay, when you see this truth table, then okay, who has this functionality? Who has this functionality? When you see this truth table, you can notice this is your s1 s0. So when these are 1 1, then f3 will, then f will be w3. when these are when these are 1 0, then this is w2. So this is what I am saying. So when these signals s1 s0, when these signals are 0 0, output is w0. When these signals are 1 0, output is w2. So when you see this truth table, then what you remember, this is a multiplexer. This is a multiplexer, correct? This is a multiplexer. This is a 4 by 1 multiplexer. This is the 4 by 1 multiplexer. This is a multiplexer which is 4 by 1. In a multiplexer, this happens. This situation happens in the multiplexer, that there is only one output. In multiplexer, there is only one output. Multiplexer has only one output. Okay, so this is a multiplexer, and these are the data inputs. These are the data inputs: W0, W1, W3, W2, W3. Okay, so these are the data inputs. So this is a multiplexer. In a multiplexer, we have single output. This is the single output. In a multiplexer, we have single output. And you can notice these okay, these are the data inputs. You can notice the same table you will get here. The same table you will get here. So what will happen? If these are 0 0, if these select line, if these are 0 0, then this data will go to the output. Okay, this data will go to the output. If these are 0 1, if these are 0 1, if these are 0 1, then this data will go to the output. This data will go to the output. So this is w1. And if this is 1 0, then this data w2 will go to the output. And if this is 1 1, then w3 will go to the output. So the answer will be what? Answer will be that this is a multiplexer. Is this clear? This is the question. Can you analyze a given circuit? In the exam, in the GATE exam, they will give you some circuit. Any circuit they can give you. Okay, they can give you some new circuit, they can give you, and you have to analyze. You have to improve your analytical skills. And this circuit is very simple. Look at this circuit. In this circuit, you have, okay, remember, these are inside what you have, that is just a symbolic. See, inside what you have, that is just a symbol. Like this is a symbol for enable. This is a symbol for enable. This is a symbol for LSB. This is a symbol for MSB. Okay, so like this. Now, these are the inputs. This W0, this is the input. This W1, this is the input. Now, this circuit on your screen, what is this circuit? In this circuit, you have single output. If you notice, in this circuit, we have single output we have. In this circuit, we have single output we have. Okay, and you can check it out. Okay, you can see the behavior. I told you the behavior. So this is the behavior. So finally, I can say this circuit is your multiplexer. Is this clear? So the given circuit is a multiplexer. This circuit is a multiplexer. This is a 4 by 1 multiplexer we have created from decoder. Can you notice? This is a 4 by 1 multiplexer. We have created this using decoder. From 2 by 4 decoder, this is the decoder. From this decoder, we have created multiplexer. This is the multiplexer, and this is the decoder. This is the decoder. This is the multiplexer. So from decoder, we have created multiplexer. And very simple, this is the analysis. You can notice. Okay, if both the inputs are 0 0, this line will become active, and so f will be equal to w0. Okay, and so on. So is this analysis clear? So your circuit is basically multiplexer. Okay, so you already know what is your multiplexer. This is the multiplexer. You can notice. This is your multiplexer. This is the SOP implementation of multiplexer. SOP implementation. This is the SOP implementation of multiplexer. We already know. Correct? Anyone has any doubt in this? So this is how you can create. Remember, in the exam, they can give you any circuit. In the exam, they can give you this circuit, they can give you, and they will ask you what this circuit is doing. What is the behavior of this circuit? They will ask you. So you can analyze. Okay, if I give you this circuit, you can analyze. What you can do? You can just put the values and you can analyze. You can put these values and you can see what is happening. You can put these values and you can see what is happening. You can put these values and you can see what is happening. So like this, 1 1 W3. Okay, so finally you can find out that this is a multiplexer. We have created a multiplexer. Is this clear? Any doubt, anyone? So remember, you can create multiplexer from decoder. If you have decoder, from the decoder you can create multiplexer. Okay, if I give you any decoder, like for example, you can create 2 by 1 multiplexer. Let's create 2 by 1 multiplexer using 1 by 2 decoder. This multiplexer we need to create from 1 by 2 decoder. Let's create this. So how will you create? Very simple. See what you want. You want this multiplexer, you want. This is what you want. Okay. You want this multiplexer, means this 2 by 1 multiplexer you want. This type of multiplexer you want. This is what you want. Okay. So if this is your input W0, W1, W0, W1, this is 0, this is 1. Remember, this 0 just tells you, okay, this is the 0. Now here, this is what you want. So what you want that when s is 0, then f should be W0, and when s is 1, then f should be W1. This is what you want. And what you have, tell me what you have. This is what you have. This 1 by 2 decoder you have. 1 by 2 decoder. This 1 by 2 decoder you have. Correct? Okay, so this 1 by 2 decoder you have. This is your input s. So this decoder you have. Now in this decoder, you already know, from this decoder we want to create this multiplexer. This multiplexer we want to create. So how to create? Tell me how can I create from this decoder? How can I create this multiplexer? So this decoder is given to you. Very simple. When s is 0, remember output should be W0. Remember, when s is 0, then output should be W0. So when s is 0, if I take s is 0, then what will happen? Tell me. If I take s is equal 0, then what will happen? Then this line will become activated. This line will become activated. When I take s equal to 0 in the decoder, this is a decoder. This is a decoder. Now, if I take s equal to 0, then this line will become activated. This line will become 1. But what we want W0. When s is 0, when this s is 0, we want W0. Okay, we want W0. So what I can do, very simple, I can do like this. Okay, I can connect W0 here, and I connect this line, I can connect here. Now you can notice I will get W0. Okay, here I will get W0. I will get W0. Similarly, if s is equal to 1, if s is equal to 1, then what will happen? Then this will become activated. Then this line will become activated. But what I want, when s equal to 1, then I want W1. I want W1. Okay, when s equal to 1, then I want W1. So I connect W1 here. So I will get W1 here. Finally, what I can do, very simple. So this is what I am doing. I am connecting this line. Okay, so to this I am creating AND gate. Okay, here also I am creating AND gate. Now this I am connecting W0. This I am connecting W1. Okay, so this line I am connecting here. This line I am connecting here. And then finally you can take there or. You can take there or you can take. Now you can notice this is your multiplexer. This is your multiplexer. This is your multiplexer using decoder. This is your 2 by 1 mux. Okay, this is your 2 by 1 mux using 1 by 2 decoder. Is this understood? Anyone has any doubt in this? Very simple implementation. Quite simple implementation. If you have any decoder, like okay, any decoder you have. For example, if you have, let us assume that you have, you want to create 4 by 1 mux. This is what you want to create using 1 by 4 decoder. From this decoder, so you have this decoder. What you have? You have this decoder you have, and from this decoder, this is your decoder. Okay, where you have S0, S1, where this is MSB, this is LSB. Okay, this is MSB, this is LSB, and these are the outputs. These are the outputs 0, 1, 2, 3. These are the outputs. Now from this, what we want to create, we want to create multiplexer. But you already know what is 4 by 1 multiplexer. This 4 by 1 multiplexer you want to create, and you already know what is 4 by 1 multiplexer. In a 4 by 1 multiplexer, we have 4 data inputs. There are 4 data inputs, W0, W1, W2, W3. So these are the 4 data inputs we have, and there are 2 select lines, S1, S0, and there is one output. Okay, now you can notice if they are 0, 0, if this S1, S0, if they are 0, 0, then your output must be equal to W0. If they are 0, 0, like if I take these 0, 0, then what will happen? If I take these are 0, 0, then this line will become activated. if I take them as 0 0, this line will become activated. So I can connect this with, I can connect this line here, and I can connect W0 here. Okay, this W0 I can connect here. Similarly, I can connect this line here. Okay, this line here, and I can connect W2 here. This W2 I can connect here. And similarly, I can connect this line, I can connect here, and I can connect W3 here. Sorry, W. Here I can connect W1. Okay, here I can connect W1. Here I can connect W2. And then finally, this I can connect with the AND gate, and I can connect this with W3. And then finally, all these things will go to the OR gate. Okay, all these things, they will connect to the OR gate, and this is your multiplexer. This is how you can create the multiplexer. Okay, very simple concept. So this is how you can create the multiplexer from decoder. The implementation of multiplexer from decoder is straightforward. Very simply, you can do this type of situation. Okay, you can do this type of implementation. Is this clear? So quite simple. Now remember, just to tell you, how to create. If I want to create 8 by 1 mux, if I want to create 8 by 1 mux using 3 by 8 decoder, so this is your 2 by 4 decoder. This is your 2 by 4 decoder. Okay, so here what I'm saying, now if you want to create 8 by 1 mux, you want to create from 3 by 8 decoder, using 3 by 8 decoder, then how will you create? Let me just give you the template. The template is like this, very simple template. This is your decoder, this is your 3 by 8 decoder. Okay, and this is 0 1 2 and so on, total 7. And these are the input lines, S0, S1, S2, where this is LSB and this is MSB. This means that this is MSB, and this means that this is LSB. Now in this situation, how to create the we want to create multiplexer. Very simple, very simple. Because if all are 0, then output must be this F. Okay, this output must be equal to W0. When all are 0, then this line will become activated. This line will become activated. So what I can do, I can create this AND gate here, and I can put W0 here. Okay, like this. Similarly, what I can do, I can connect this line, I can connect to AND gate. Okay, and also I can connect this to W1, like this. Okay, so this is how you can do. This line I can connect to AND gate. Okay, and I can connect this to W2. And finally, what I can do, I can connect this to AND gate. Okay, I can connect this to AND gate, and I connect this to W7. Okay, so like this you can create the multiplexer. Very simple. Now let's move on. So this is your multiplexer. This is how you can do multiplexer. Remember, in the GATE exam, they will not ask you this. What they will ask you? In the GATE exam, they will not ask you, can you create? Yes, you can create. So we can create. Remember, if you want to create 2 power n by 1 multiplexer, okay, this multiplexer can be created, can be implemented. How can I implement this? Can be implemented using which decoder? This can be implemented using n by 2 power n decoder. Okay, so this multiplexer you can implement using this decoder plus AND gates plus one OR gate. Okay, so like this you can implement. Very simple. So this multiplexer you can create from the decoder. And in the GATE exam, what they will give you? Remember, in the exam they will give you this type of circuit. In the exam, this type of circuit will be given to you, and they will ask you what this circuit is doing, what is the behavior of this circuit. Okay, so this is, and the options will be like, this is multiplexer, this is demultiplexer, encoder, decoder. Okay, so this type of options will be there. So this type of questions they will ask you. Now, okay, so we can create multiplexer using decoder. Very simple. Now let's move on. Let's move on now. Now let's analyze this question, the question number 2. This is our question number 2. So tell me the answer for this question. What is the answer? A demultiplexer. The question is saying that a demultiplexer can be created, can be implemented using a decoder. For example, 2 by 4 decoder can be used to create 1 by 4 demultiplexer. Which input serves as the data input of the demultiplexer? So in this decoder, which input which input will will work as data input? If you want to create demultiplexer, then what will be the answer? Tell me, what will be the answer? You already know what is demultiplexer, right? Okay, so this demultiplexer you already know. For example, this is your 1 by 2 demultiplexer. This is the 1 by 2. Here you have data. This is your data input and this is your output. Okay, 0 1, this is your output and this is the selection line. This is your demultiplexer. This is called DeMux. We call it DeMux. This is your 1 by 2 DeMux. In this 1 by 2 DeMux, what happens? Tell me. This like this happens. If this S is 0, if this S is 0, then what will happen? This data will go to this output line. Okay, if this S is 0, let's call it Y0 and let's call it Y1. So like this will happen. If this S is 0, if this S is 0, then this data will go to the Y0. If this S is 0, this data will go to Y0. Okay. And if this S is 1, if this S is 1, if this select line is 1, then the data will go to Y1. This data will go to Y1. Okay. So this, if S is 1, then data will go to Y1. This is your demultiplexer. This is your 1 by 2 DeMux. Okay. Now, how to do? Okay, if I have, so this is your DeMux, you already know. This is your demultiplexer. This now, if I have 2 by 1 decoder, then how to create? Let us assume I have 2 by 1 decoder. This decoder I have. So from this decoder, how can I create? Let's assume this is my decoder. Sorry, 1 by 2. Sorry, I have 1 by 2 decoder. So let's assume I have 1 by 2 decoder. This is my decoder. Let's assume I have 1 by 2 decoder. See, this is your 1 by 2 multiplexer. So this is your 1 by 2 demultiplexer. I have 1 by 2 decoder. Okay, this is your select line. And these are your, I can say, okay, you can call it Y0, you can call it Y1. And this is your enable signal. This is your enable signal. Now tell me, if I want to create demultiplexer from this, how can I make this work as demultiplexer? Tell me. I want to use this as a demultiplexer. This is a decoder. You already know this is a decoder. Remember, this is a decoder. Means what it means? Because decoder means if this is 0, if this S is 0, then this Y0 will be 1. If this S is 0, then this will become activated. This will become activated. And if this S is 1, if this S is 1, then this Y1 will become activated. Okay, this is your decoder. You already know. This is the decoder. This is your 1 by 2 decoder. If I want to use this decoder as a demultiplexer, then what should I do? Can I use, okay, like which should be my data input? In the demultiplexer, we have data input. This data input we have. In the demultiplexer, we have data input. This data input we have. And we have select line. And we have select line. So tell me, what should I do? If I want to create, if I want to convert this into the demultiplexer, then what should I do? Remember, this will work as select line. Yes. Okay. This will work as select line for the demultiplexer. From the decoder, I want to create demultiplexer. From this, I want to create this decoder. I want to convert into demultiplexer. Then what I can do? I can use this as select line. Okay. This I can use as select line. I can use this as select line. These will be my output. So automatically this will work as data input. This will work as data input. Now let's check it out. Is this working correctly? If I take this as data input, is this working correctly? Tell me. In a demultiplexer, if your data input is 0, this is your demultiplexer. If your data input is 0, then what should happen? In a demultiplexer, let's assume this is your demultiplexer. And if your data is 0, let's assume if your data is 0, okay, then tell me what will happen if your data is 0 and this is your select line. If your data is 0, then what will happen? If the data is 0, Y0, Y1. If your data is 0. Now, if S is 0, then data will go to Y0. If S is 0, the data will go to Y0. If S is 0, the data will go to Y0. So this data will go to Y0. Remember, this is data. If S is 1, then this data will go to Y1. Okay. If this s is 1, if this s is 1, then data will go to y1. The data will go to y1. The data, this is the data, and this data will go to y1. So can you notice this is actually your data? This is actually your data. So in the demultiplexer, if the data is 0, then this happens, correct? If in demultiplexer, this is your demultiplexer. In the demultiplexer, if data is 0, if data input is 0, then this happens, correct or not? Then this happens. If data input is 0, then this will happen, correct? Now you can notice that if I take this enable I am taking as a data input. This enable I am taking as data input. Now let's see. This is a decoder. Tell me what will happen. If enable is 0, then what will happen? Tell me. If the enable is 0, then what will happen? If the enable is 0, then what will happen? In the decoder, if the enable is 0, then it does not matter what you have here. It does not matter what you have here. Okay, this will be 0, this will be 0. Tell me, is this the behavior we want for demultiplexer? If I use this as data input, do we want this behavior for demultiplexer? Do we want this behavior for demultiplexer? Tell me. Do we want this behavior for demultiplexer? Yes, of course. Yes, of course, yes or no? Because you know that in a demultiplexer, if the data input is 0, then demultiplexer will be like this. Okay, if the data input is 0, then in the demultiplexer, these will be 0. Both will be 0 if the data is 0. Then in the demultiplexer, so I can say in demultiplexer, if the data input is 0, if this data input is 0, then all outputs are 0, correct or not? Then all outputs are 0 irrespective of, okay, regardless of select line, regardless of select lines. Okay, in the demultiplexer, if your data is 0, then regardless of select line, all the outputs will be 0 because your data is 0. This is actually the data, so the data is 0, so automatically all the output lines, all these output lines, they will become 0 regardless of what is your select lines. So you can notice what I am saying, that if I use this enable, as a data input, then yes, this behavior is fine. This is what we want in the demultiplexer. This is what we want in the demultiplexer. Now if the enable is 1, then tell me what you want. Enable is 1, remember this is your data. Okay, because I am using this enable as a data input. So if enable is 1 and s is 0, enable is 1, s is 0, then this line will become active, this line will become 1, so this y0, this will become 1, and this is what we want. This is what we want in the demultiplexer. In the demultiplexer, now this is your data and the data is going to y0, and similarly now this is your data, and if s is 1, then this line will become activated, and this is what we want. If the data is 1, then if s is 1, if this select line is 1, then the data should go to y1. So everything is fine. Did you understand this? Let me know. Please tell me, did you understand this? Okay, let's take one more example. See, okay, compare these two parallelly. Okay, one by one, parallelly you compare these two. So on one side you compare 1 by 4 mux, DMux. Let's see 1 by 4 DMux. This is your 1 by 4 DMux. In the DMux we have S1, S0. This is your data input, and this is your 4 lines. This is your 4 output lines. Okay, so the 4 output lines are Y0, Y1, Y2 and Y3. These are the 4 output lines, correct? Okay, and you have on other side you have 2 by 4 decoder. In the 2 by 4 decoder, what happens? We have two input lines. There are two input lines which are S0, S1. Okay, which are S0, S1. This is LSB, this is MSB, and there are 4 output lines. The 4 output lines are, I can say, Y0, Y1, Y2, Y3, and there is one enable. This is the enable input. Now how to convert? If I want to use this decoder as a demultiplexer, then how to convert? Remember, this is your demultiplexer. In the demultiplexer, on one side I am making the table of demultiplexer. In the demultiplexer, what will happen? This is your data. Okay, let's make the table for demultiplexer. So in this is your data, and this is your select line. This is your data, this is your select line. Okay, and the outputs are y0, y1, y2, y3. These are the outputs. So tell me, please tell me, if this is, if the select line is 0, and let's assume data is also 0. If the select line is 0, okay, if the select line is 0, data is 0. If the data is 0, select line is 1. Next, if the data is 1, select line is 0. If the data is 1, select line is 1. So these are the 4 possibilities. Tell me one by one for all of them, what will be this row? In the demultiplexer, tell me, this is your demultiplexer. You know what is demultiplexer? There is data input. This is the data input. In the demultiplexer, this is the data input. Okay, and you know that when these will be 0, 0, when these will be 0, okay, so you have S1 as 0. Okay, you have S1 as 0. You have S1 as 0. Okay, you have S1 as 0. So let's assume this data is 0. Then, okay, so, okay, consider this situation. I'm not taking all the rows, but I'm taking only the few ones. For example, okay, this type of things I'm taking. So tell me what will happen here. So you can notice this is your demultiplexer. In the demultiplexer, this is the data input. This D is the data input. Okay, and you know that when these are 0, 0, then what will happen? When these are 0, 0, this data input will go to y0. When these are 0, 0, like when these are 0, 0, the data input will go to y0. The data input will go to y0, other will be 0. Remember, this is data. Please understand, this is data. You know that if both are 0, 0, then this y0 will be equal to data. This data will go to y0. If these are 0, 0, then this data will go to y0. This data will go to y0. But you can notice that here the data is 0. The data is 0. So y0 will be 0 and all other will be 0. So this is what you need to understand. Okay, next, when these are 1, 0, then what will happen? When these are 1, 0, S1 S0, when these are 1, 0, these two, when these are 1, 0, then this data will go to y2. This data will go to y2. So y2 will be equal to data. This y2 will be equal to data, and other will be 0, 0, 0. This is what I am saying. Are Satyajit, data is 0. This 0 is actually the data. Please understand. This 0 is actually the data. This 0 is actually the data. This 0 is actually the data. Okay, because when these are 0, when these are, for example, when these are 0, 0, then this data will go to y0. This y0 will be equal to data, but your data is 0. But your data is 0, so y0 equal to 0. Tell me, is this clear? Is this concept clear? Next, if these are 0, 0, now your data is 1. Now your data is 1. If these are 0, 0, then your data will go to y0. Your data will go to y0 and other will be 0, 0. When this is 1, 0, then data will go to y2. Data will go to y2, other will be 0, 0. And when this is 1, 1, then data will go to y3. Data will go to y3, other will be 0, 0, 0. This is your demultiplexer. Is this understood? Anyone has any doubt in this? Very simple. Now let's see the same thing for decoder. Assume that, okay, in decoder, assume that enable is your data. Assume that enable is working as data input. Assume that, okay, assume that enable is working as data input. If enable is working as data input, okay, so this okay, so let's see this decoder. In the decoder, what will happen? This is your en, this is your s1, this is your s0, and you have y0, y1, y2, y3. The same rows I will take. Okay, so let's take the same rows. 0 0 0 0 1 0 1 0 0 1 1 0 and 1 1 1. For the same rows, what will happen in the decoder? In the decoder, what will happen? For the same row, for the same combination in the decoder, what will happen? In the decoder, because this is 0 0, in the decoder, if this enable is 0, then what will happen? Tell me. If this enable is 0, then what will happen? Tell me. All will be 0. If this enable is 0, then all will be 0. If this enable is 0, then all will be 0. Correct? Very simple. If enable is 0, then all will be 0. Now, if the enable is 1, then it will work. If the enable is 1, then it will work. If these are 0 0, enable is 1, enable is 1. If these are 0 0, then this line will become 1 and these will become 0 0. Okay? If the enable is 1, if these are 0 0, this will become active and these will be 0 0. So in this, what will happen? This will become active and these will be 0 0. Next, in this situation, this will become active, this will be 0 0. In this situation, this will be active, this will be 0 0. Can you notice both are same? Can you notice that decoder is same as demultiplexer? If you think of encode this enable as, this enable is working as data input. This enable is working as data input of DeMux. Okay, this is working. This is working as data input of DeMux. Is this understood? Anyone has any doubt in this? Let me know. So this is what I am saying, that you can convert decoder into demultiplexer. You can convert the decoder into demultiplexer very easily if you have decoder. Okay, for example, if you have n by 2 power n decoder, if you have this decoder, you have. Now, how to convert this into demultiplexer? How to convert this into demultiplexer? How to convert this into to 1 by 1 into 2 power n demultiplexer? How to make that? So what you need to do? The first thing you need to do, the enable will be your data input. Okay, so the enable will work as the data input. The second point, these select lines will work as these n input lines of decoder. The n input lines of decoder, they will work as what? Will work as what? Will be working as what? Will work as select lines and select lines of DeMux. Okay, so this is how you can convert. Is this clear? So very simple topic, but they can ask you question, and you can notice this is a standard university question. This question. So what I am saying, is this clear? Any demultiplexer you have, sorry, any decoder you have, any decoder. If you have a decoder, you can convert that decoder n into 2 power n decoder you have. You can convert that into 1 into 2 power 1 2 power n DeMux very easily. What you do? This enable will be connected to, this enable will work as data input. Basically, the data input will be connected to enable. What you do? You connect data input to enable. Okay, connect data input to enable. This connect data input to enable. Connect data input to enable. Okay, and what you do? The n input lines of decoder, they will work as unselect lines of demultiplexer. So this is quite simple. Connect the data input to enable. This data input of DeMux. Okay, this enable of decoder. So is this point clear? Anything you have, you can very easily do. Any circuit I give you, you can very easily create. So for example, if you have this circuit, okay, quickly let's see. Like for example, if you have 3 by 8 decoder, let's assume this is your 3 by 8 decoder, S0 S1 S2, S0 S1 S2, and this is your enable. This is your enable, and this is your Y0, Y1, Y2, and so on Yn. Right now this is decoder. At this moment this is decoder. But in this decoder, if I do these changes, some changes I do, what I do? in this decoder I make some changes. What changes I make? To this enable I connect the data input. Okay, to this enable I connect the data input, and these are my select lines, okay, these inputs they will become my select lines, and this enable I will connect to data input. The data input I will connect to enable, and everything else is same. Now right now this is decoder. Now this has become DeMux. Here these are the select lines, and here these are the input lines. Okay, for decoder these are the input lines. For decoder these are the input lines. For demultiplexer these will become select lines. Okay, so the input lines of decoder will become select lines of demultiplexer. And what I will do, the data input I will connect the data input to enable. So like this. Is this clear? So very simple. So from the decoder, this decoder you have converted, this 3 by 8 decoder you have converted into 1 by 8 DeMux. 1 by 8 DeMux. 1 by 8 DeMux, because remember this is the data input. This is your data input. And these are the select lines. So like this. I hope this point is clear. Array CS, I am connecting the enable of decoder. I am connecting my data input to enable. Is this point clear? You have decoder. You purchase this decoder from the market. You purchase this decoder. This decoder you purchase from the market. Okay, this decoder you are purchasing from the market. You are purchasing this decoder. Let's assume in the market demultiplexer is expensive. Let us assume from the market you take this. Okay, what you do, you purchase this from the market, and then after coming home, so from market you purchase this. After coming home, what you do, after coming home you want demultiplexer. What you want? You want demultiplexer. Then what you can do, tell me. From the market you will purchase this decoder, but you want demultiplexer. So what you will do, if you want demultiplexer, so what you will do, you will do like this decoder you can use as a demultiplexer. These data inputs you will use as select lines. Okay, these data inputs you will use as select lines, and to this enable you will connect your data input. You will connect here. Okay, so your data input you will connect to enable, and these input lines of decoder, these are the input lines of decoder. These input lines of decoder you will convert them to select lines. You will use them as select lines. Okay, used as a select lines. Is this clear? So we are converting decoder into demultiplexer. Please tell me now, is it clear? This is your 2 by 4 decoder, and this is your 1 by 4 demultiplexer. So from the market you purchase this, and at home what you can do, you can convert this into demultiplexer. You can convert. What you can do, you can connect your data input to enable, and you can use these data input lines, you can use them as select lines. Okay, very simple. So this is how you can do implement demultiplexer using decoder. Like this you can do. Okay, very simple. You can notice the enable. Remember, this is the idea. The enable I am connecting to my data input. I am connecting to enable, and the decoder input lines I am using them as select lines. These are the decoder input lines. I am using them as select lines, and this is your decoder enable. I am connecting my data input to this enable. So finally I will get demultiplexer. This is the idea. Now let's solve this question. So tell me what is the answer now. For this question, what will be the answer? What is the answer for this question? So the question is asking, demultiplexer can be implemented using decoder. For example, this 2 by 4 decode, this is 2 by 4 decoder. This is a 2 by 4 decoder. You can convert this into 1 by 4 demultiplexer. Which input will work as a data input? Which input will you work as data input? So the answer will be enable. This will work as data input. Okay. This is a simple question. This is a very simple question, you can notice. So this type of question they can ask. And you can notice this is a standard university question. This is a standard question. Now let's move on. I hope this point is clear. Okay. So from the market you can purchase decoder and you can convert that decoder into demultiplexer if you want. Now let's see the next question. The next question is this. How to implement function using decoder? The next question is this. So let's see this question. So tell me what will be the answer. Did you solve this question? I gave this question as a homework in the last standard session. In the last standard session, this question I gave as a homework. Did you try this? Very simple question. You can notice 2 by 4 decoders are given to you. There are two by 4 decoder. This is a 2 by 4 decoder. This is a 2 by 4 decoder. There is inverter. This is the inverter. And there is OR gate. This is the OR gate. To implement a function f, x, y, z, x is the most significant bit. X is the most significant bit. Okay, so this x, this is your MSB. This is your MSB. We are having this function f, x, y, z, and this x is your MSB. Now the question is asking that f, x, y, z can be represented as option A, B, C, D. So what will be the answer for this question? For this question, what will be the answer? So very easy. This question is very easy. Just check. This is your OR gate. Just check when f will be 1. Just tell me when f will be 1. F is 1. When f will be 1. Just tell me this point. When this f will be 1. This f will be 1 when this line, when this line is 1, correct? F will be 1 when this line is 1. Tell me when this line is 1. Tell me when this line will be 1. This line will be 1 when this line will be 1. When x is equal to, see this line will active. Remember this is decoder. Remember this is decoder. So when this line will become 1, when this will become active, this line will become active when this enable is 1, means when x is equal to 1. Enable should be 1, remember. So this line will become 1 when enable is 1, when x is 1. And these are 0, 0. Y comma z are 0, 0. Y comma z, these are 0, 0. So this is the idea. Next, tell me when this line will be 1, this last line, when this line will be 1, this line will be active. When this line will be active, this line will be active when this decoder is active. Please understand, this is a decoder. Okay, so this line will be active. This line will be 1 when this decoder is active. This decoder will be active when x is 0. When x is 0, then this decoder will be active. So when x is 0, then this decoder will be active. Okay, and when y is 1 and z is 0, remember y is MSB here. Okay, remember this y comma z is like this. Y comma z, this y is the MSB and this z is the LSB. You can notice this means LSB. Please understand, this means LSB. Okay, so this z is LSB. So I can say if x is 0, then this will be active. And when y is 1, z is 0, then this line will become active. This line will become 1. When x is 0, y equal to 1. Okay, and so on. Now let's see this one. when this line will be active, this line, when this line will be 1, in which situation this line will be 1? This line will be 1 when x is 1 and y is 1 and z is 1. X is 1, z is 1, y is 1. Now similarly, tell me, when this will be active, when this will be 1, this will be 1 when x is 0. Oh, so this we have already seen. This line we have already seen. Now let's see this line. This line will be active. Remember this line. Please understand. This line will be active when this decoder is active. This decoder will be active when x equal to 0. When x equal to 0, y equal to 0, z equal to 0. In this situation, this line will be 1. This line will be 1 in this situation. So finally, this, remember this is OR gate. Remember this is your OR gate. Okay, so this is OR gate. See, so finally I can say that this f will be 1 when in these situations x0, I can say x0, so what is x0, y0, z0, x0, y0, z0, x0, y1, z0, x1, y, x1, y0, z0, and x1, y1, z1 in these situations. Okay, so finally I can say that this f will be 1, this output function f, this output function f, this will be 1 in these situations. So I can say this f x y z, what are the true minterms? What are the true minterms? What are the true minterms? Or I can say what are the minterms? Tell me, what are the minterms? Minterms are 0, then 2, then 4, then 7. These are the minterms. The same expression I can also write as what are the max terms? What are the false max terms? So that will be 1, 3, 5, 6. So the answer will be summation 0 to 4, 7, summation 0 to 4, 7, and multiplication 1, 3, 5, 6. Multiplication 1, 3, 5, 6. So answer will be B comma C. Is it clear? This B comma C will be the answer. Okay, so you can check this B comma C. This is the answer. So this is a very simple question. Decoder is given to you. Here what is interesting? This is interesting that, okay, this will be active when x equal to 1. Okay, so this decoder will be active when x equal to 1. Because when x equal to 1, then this enable will become 1. Similarly, this decoder will become active when x equal to 0. Because when x equal to 0, then this enable will become 1. Okay, so this circuit will be active for x equal to 1. This circuit will be active for x equal to 0. Okay, so like this you can find it out. So the answer will be B comma C. Very simple. Now let's see one more question. This is a question on encoder. Let's see how to solve this. Okay, so this is a big question. I give this question to you as a homework. Okay, so you can take this question as a homework. I will take a small question. Similar question I will take, don't worry. Okay, but I will take a small question. Let me take what this question is saying. This question is saying that a priority encoder, there is a priority encoder, reads a vector of 7 binary bits. Okay, so reads a vector of 7 binary bits and produces a binary number. So let me take a small question. Let me take 5 binary bit. Okay, so let's take priority encoder. Let me change the question. Okay, I am changing the question little bit. This question you can take as a homework, but I am solving a similar question but a smaller one. What I am doing? I am doing this. A priority encoder reads a vector of 5 binary bits. Let me take 5 binary bits. Let me take 5 binary bits. Okay, just for understanding purpose, I want to explain. So let me take 5 binary bits. Okay, next, it will produce a binary number of 3. A binary number it will produce. Next, that presents. Okay, or let's do this. Okay, let's solve this entire question. Okay, let's solve this and this entire question. Let's solve this. Okay, so let me solve this entire question. Okay, because the question is interesting and the question is easy. This is a question on priority encoder. What this is saying, there is a priority encoder. So we have a priority encoder. So this encoder we have, and this encoder, this reads a vector of 7 binary bits. means the input is 7 bits. Okay, so this is your input. The input is 7 bits. I can say A0. So this is your input. A0, A1, A2, A3, A4, A5, A6. So 7, there are 7 inputs. And what it does, it produces a binary number that, okay, so binary number will be produced. So remember, this is an encoder and it will produce a binary number D0, D1, D2. Okay, this will produce a binary number. And now, because this is priority encoder, so what will happen? Can anyone tell me? Because this is priority encoder, so what will happen? Tell me. This is a priority encoder. So because this is a priority encoder, so just think about it and tell me, if this is a priority encoder, then there is a priority. We must know what is the priority. Yes or no? Like who has the more priority? Because this is a priority encoder. This is your priority encoder. So you must know who has the more priority. This is your priority encoder. So tell me, just tell me this point. Just tell me this point. Let us assume that let us assume this is also one, this is also one, this is also one, this is also one, and these are 0 0. Then what should be my output? Tell me, what should be my output? This is a priority encoder. So if all these are 1, this is a priority encoder. So in the priority encoder, multiple input can be 1. I told you this point in the class. Multiple inputs can be 1. Can be 1. Okay, but the output will be same as the highest priority. Output output will be for highest priority input. For highest priority input, the output will be for the highest priority input. This is your priority encoder. I told you in the class very very clearly. I told you this is a priority encoder. In the priority encoder, I told you that multiple inputs can be 1. Multiple inputs can be 1. Okay, multiple inputs, they can be 1. But remember, the output will be for the highest priority input. So we have to find out, if these are 1 1 1, then who has the highest priority? Okay, and this is given in the question. In the question, this information is given. What the question is saying? The question is saying that when you read this input, then you will produce this output. When you read this, you will produce this output that presents the lowest index of input bit, which is true. What it means? Who is given more priority? Tell me. For example, when this is equal to, when your input is like this, if your input is like this, then your output is same as the lowest index. The output is same as lowest index. You can notice that the output will be same as A2. The output will be same as A2. Similarly, the output will be same as A5. The output will be same as A5. Similarly, in this situation, output will be same as A0. The output will be same as A0. So did you understand who has the more priority from the question? From the question. Remember this point I told you in a priority encoder. This is the difference between priority encoder and normal encoder. Priority encoder and normal binary encoder. Normal binary encoder. There are two type of encoder. One is priority encoder, another is normal encoder, or I can say binary encoder. In this, multiple inputs can be 1. In this, exactly one input is 1. In this, exactly one input can be 1. Can be 1 at a time. Okay, in this. And in this priority encoder, multiple inputs can be 1. Multiple inputs can be 1. Okay, and when multiple inputs are 1, then output will be same as the highest priority input. So who has the highest priority? So it simply means, the question is simply saying that this lowest index, the lowest index has highest priority. This lowest index has the highest priority. This has the highest priority, and this has the lowest priority. This is given in the question. See, read the question, Priya. Read this question. What this question is saying, that when you read this input, The question is saying that you have a priority encoder. Okay, this is what question is saying, that you have a circuit, you have a priority encoder. What this priority encoder will do, it will read the input, it will read the input, this input it will read. Like I can say this is your input, 7-bit input is there, there is a 7-bit input, we have 7-bit input. Okay, so you will read this 7-bit input, this is your 7-bit input. So you will read this input, and what you will do, you will produce the output. Okay, after reading this, you will produce this output, this d2, d1, d0, this output you will produce. Okay, so this output will be produced now. Okay, and this is saying that, the output is same as, the output represents the lowest index of the input, which is true. Please understand, the output indicates the lowest. Okay, this output, this indicates the lowest bit, which is true. For example, if I give you these, in this situation what will be the output, tell me? In this situation what will be the output? Your output will be, because this is the lowest index, this has highest priority, a0 has highest priority, a0 has highest priority, and this is 1, so the output will be 0 0 0. Is this clear? Next, tell me, in this situation what will happen? Tell me, in this situation what will happen? In this situation, please tell me, in this situation what will happen? What will be the output in this situation? Remember, this has the priority, this has more priority, so lowest index which is 1, lowest index which is 1, so output will be 1, output will be 1. Okay, so this will be like this. Is it clear to everyone? Let me know, anyone has any doubt in this? And let's assume in this situation what will happen? In this situation what will happen, tell me? In this situation what will happen? In this situation, this is the only active, this is 1, this is the only one. So in this situation what will happen? So you will get 5 1 0 1. So is this question clear? Read the question, the question is very simple, and the question is standard question. You can notice this type of question they give in the exam, every detail is there. In this question you have every detail, there is no ambiguity, this is a well framed question, every information is given to you. So did you understand the question? So the question is very simple, that this is a priority encoder, this is your priority encoder, this is your priority encoder, where, and the question is saying this has the highest priority. This is what question is saying, that this has highest priority and this has lowest priority. Okay, and the priority is decreasing, the priority is decreasing. So now let's make the table. The question is asking what you need to do. Okay, and the question is also saying when none of the input bit is 1, when none of them is 1, the question is saying when none of the input is 1, means if all the inputs are 0 0 0, then output will be 0, then output will be 0 0 0. This is also given to you. Okay, this is also given to you. Now the question is asking derive the sum of product expression for the 3 output bit. So let's make it, let's make the table. So what table you will get, tell me? So these are the inputs, total 7 inputs you have. In a normal priority encoder, how many inputs you have? Can anyone tell me? In a normal priority encoder, how many inputs you have? What is the size of normal, like the standard priority encoder? What is the size of standard priority encoder? That is 2 power n by n. Yes or no? 2 power n by n. This is the standard priority encoder. This is the standard. A standard encoder will have this size. 2 power n by n. Correct? But remember, this is in the question they are giving this encoder which has only 7 bits. The data input is only 7 bits, A6, A5, A4, A3, A2, A1, A0, and the output is, what is the output? That is D2, D1, D0. Now let's fill this table. Let's fill this table from the question. So tell me, in this situation what will happen? If all are 0, then what will happen? Tell me. If all are 0, when then what this question is saying, if all are 0, if all the inputs are 0, if all the inputs are 0, you can notice if all the inputs are 0, then output will be 0 0 0. This is the question saying, the question has given this information, the output will be 0 0 0. Next, tell me in this situation what will happen. Let us assume this is 1. If this is 1, does it matter what are these? Tell me, in this situation, does it matter what are these? Does it matter what are these? Does it matter what are them? Because this has highest priority. Remember, this has highest priority. Yes or no? This has highest priority. So tell me, now in this situation, does it matter? This has highest priority. So if this is 1, then they are don't cares. They are don't cares. If this is 1, if this is 1, it does not matter what are these. It does not matter whether they are 1 or 0. It does not matter. Okay, these do not matter. These do not matter. If this is 1, if this is 1, then output will be, what will be the output? Tell me in this situation. For this case, what will be the output? Tell me. Very simple. Okay, the output will be same as the encoding of A0. The output will be encoding of A0. Encoding of A0. Okay, next. If this is 0, this is 1. If this is 1, then they are don't cares. It does not matter what are these. If this is 1, then output will be what? Then output will be 0 0 1. Output will be encoding of A1. Output will be encoding of A1. Encoding of A1. Similarly, what you can do? Okay, if this is 1, this is 0 0, then these are don't cares. These are don't cares, and the output will be encoding of A2. Encoding of A2 will be the output. Encoding of A2. Encoding of A2 will be the output. Okay, so the output will be 0 1 0, and so on. Finally, for example, if this is 1 and all are 0, then what will happen? If this is 1, all are 0. In this situation, what will happen? Then output will be encoding of A6. Output will be encoding of A6 like this. Okay, so like this you can create the whole table, the complete table you can create, and you can check it out. This is your complete table. This is the complete table on your screen. This is the complete table. Okay, now tell me, this is compact truth table or standard truth table? Is this compact truth table or standard truth table? What is this? This is compact or standard? This is compact truth table. Because tell me, in the standard truth table, how many rows will be there? If I create the standard truth table, then how many rows will be there? How many rows in the standard truth table? Because there are 7 inputs, so number of rows will be 128. This is a compact truth table. This is the compact truth table. This is compact truth table. Because there are 7 inputs. There are 7 inputs. So if you make the standard truth table with the 7 input bits, if you make the standard truth table, there will be, in the standard truth table, how many will be there? A standard truth table will have 2 power 7, 128 rows will be there. Is this clear? So total 128 rows will be there. But this is a compact truth table because total 7 inputs are there. Total you have 7 inputs. These are the inputs. These are the outputs. So total 7 inputs are there. With the 7 inputs, if you create the standard truth table, there will be 128 rows. So this is your compact truth table. Now, in this truth table, how to find the equation of D2? Let's find out the equation for D2. So tell me, what is the equation for D2? When D2 is 1, just look where D2 is 1. See, D2, this D2 is 1 here, here, here. In these 3 situations, D2 is 1. Correct? So D2 is 1 in these 3 situations. What are these situations? Tell me, what are these situations? This D2 is 1 in these situations. In this situation, D2 is 1. In this situation means A4 must be 1, this must be 0, this must be 0, this must be 0, this must be 0. So D2 will be equal to A4 must be 1, this must be 0, this must be 0, this must be 0, this must be 0, or 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 okay, a5 must be 1, this must be 0, this must be 0, this must be 0, this must be 0, this must be 0. So I can say a5 must be 1, this must be 0, this must be 0, this must be 0, this must be 0, this must be 0. Or you can notice a6 must be 1, the others must be 0. a6 must be 1, the others must be 0. Okay, this must be 0, 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 this must be 0. So like this you can create the equation, correct? Is this clear? So like this you can create the equation. Remember d2 is 1 in this situation, that a4 must be 1, the others must be 0. a4 must be 1 and this a3, a2, a1, a0 they must be 0. So you can notice a4 must be 1, these remaining these must be 0. a5 must be 1 and these must be 0. Like a5 must be 1, these must be 0. Similarly a6 must be 1 and these must be 0. So finally your equation for d2 will be this. This will be your equation for d2. Is this clear? Can anyone write the equation for d1? Anyone write the equation for d1? What will be the equation for d1? Tell me. Let's write the equation for d1. What d1? See, d1 is 1 here, here, here. So if you want to make d1 1, then you can notice a2 must be 1, these must be 0. Okay, a2 must be 1 and these must be 0. Or you can notice a3 must be 1, these must be 0. a3 must be 1 and these must be 0. Or the same thing, a6 must be 1 and the remaining must be 0. So this is the equation for d2. Is this clear? And let's write the equation for d0. What is the equation for d0? This is the d0. So for d0 what will happen? This is the d0. You can notice a1 must be 1, a0 must be 0. a1 must be 1, a0 must be 0. Or next a3 must be 1, this must be 0, this must be 0, this must be 0. Or you can notice a5 must be 1 and the remaining must be 0. a5 must be 1 and these remaining they must be 0. So like this you can write the equation. Is this understood? Did everyone get this question? So very nice question, but in the exam if this type of question will come in the exam, then they will ask something else. But the question is very standard question. You can notice every information is given to you. In this question every information is given to you, every information you have. So the information is given that this is a priority encoder, okay, and every information is given who has more priority, which input has more priority, which input has less priority. Everything is given to you in this question, every information you have. And finally you will make this table. This table you will get, and from this table you can write the equation for output. You can find out the equation for 3 output. This is what you can find. So finally these equations you will get, you can check them. Okay, these are the equations you will get. Okay, so this is enough for today. So we have done total 4 questions we have done. Okay, 4 analytical questions we have done. One question we have done on priority encoder. Okay, a nice question, because remember normally the priority encoder will have 2 power n inputs and outputs. But in this question if you notice, in this question 7 inputs bits are there. In this question the input bits are 7. So there are 7 inputs and there are 3 outputs. Okay, 7 inputs, 3 outputs, and every information is given to you. And in this question you can notice this has the more priority, this lowest index has more priority, this lowest index, this has more priority, and this has least priority. So this is a question on encoder. We have seen one question on encoder, one question on function implementation using decoder, one question on how to create multiplexer from decoder, how to create demultiplexer from decoder. So total 4 questions we have seen. Tell me, did you understand all these 4 questions? In this lecture, we have seen total 4 questions. All these are standard questions. Total 4 questions we have seen from standard resources. 4 standard questions we have seen. Okay. The first question was that from decoder, how can you create multiplexer? The second question was from decoder, how can you create demultiplexer? And the third question was from decoder, how can you implement a function implement? And the fourth question was priority encoder. So these 4 questions we have seen in this video, in this standard session. Okay, all the 4 questions are very nice questions. In the gate exam they can come. Okay, and remember, in the gate exam they always ask standard question. Like in the gate exam, many standard questions directly come. This is the beauty of gate exam, that in the gate exam you will notice that many standard things many standard things they directly ask. The standard things are directly asked. So that is the reason we are teaching you these standard questions. Okay, we are collecting the standard questions from the resources and we are teaching you. Is this clear? Tell me. Okay, so see, this is what we are doing. I am collecting, like myself, in the digital logic we have seen total 4 standard sessions we have done. Okay, total 4 standard session we have done. In all these 4 standard sessions you will see that there are very nice questions. In the standard session 3 we have taken k-map question. Yes or no? 4 k-map question. The very nice question, total 4 k-map question were there in the standard session 3. And similarly, in the previous standard session also there were some nice questions. In all the standard sessions, okay, for all the subjects there will be standard session. Very soon we will start standard session for theory of computation, for discrete mathematics, for graph theory. Okay, already data structure standard sessions are already available on the goclass YouTube channel. Okay, so you can check it out. Data structure standard question session playlist on the goclass YouTube channel, you can find it out. Okay, and similarly for every subject there will be standard question sessions. And let me promise you one thing, we will not waste your time. See, from the moment we start till the end we only teach you concepts. Okay, like we don't do any promotion. We don't want to do any time waste. We don't do any time waste. Okay, have you seen this? Okay, in all the standard sessions you can see that from the start, okay, from the time we start and to the end we only teach you concepts. There is no time waste, there is no promotion, nothing. Okay, we don't do any promotion of go classes. Okay, because I personally believe that quality speaks. Okay, so when students will see the quality, they will automatically join. So we don't need to do the promotion. Okay, so that is the reason we don't waste your time by doing promotion and all these things. Okay, but this is our request to you, that if you like our session, if you like these questions, these standard sessions, if you like the efforts, okay, if you find that okay questions are brilliant, wow, okay, maza aa gaya, theek hai, then you should share this video. Okay, you can press the like button, you can comment. Okay, what is your review, you can comment. And of course uh, you can share the video with your other aspirants. Okay, so you can share that. Okay, thank you everyone. Okay, so someone has come to the chat. Okay, some spammer has come, you can notice. Okay, what these people do, I like. Okay, so okay, thank you everyone. So now let me give you some questions. Okay, some homework questions. These are the homework questions. So let me give you the homework questions. So these are the homework questions, and you should write your answer in the comments. Okay, so after every lecture, after every standard session, I will give you some homework. Okay, so these homeworks are quite easy, like these are not complicated. Every concept that you need to know to solve these homework we have already covered. Every concept that you need to know, that you need to understand to solve these homework questions, we have already seen in our lectures or in our standard sessions. Okay, in our digital logic course we have already seen all the concepts, all the variations, all the proof, everything we have seen. Okay, so you can take these homework questions. This is the homework question 1. This is the homework question 1. So this is the K-map question. What you have to find out? You have to find out in this homework question, you have to find out for both of them. For both of them, you have to find out number of PI, number of prime implicant, number of essential prime implicant, and also what is the number of minimum SOP. What is the number of minimum SOP expression? What is the number of minimum SOP expressions? So this is what you have to find out. Okay, in this homework there are two questions, this question, this question. For these two questions you have to find out number of prime implicant, number of essential prime implicant, and also how many minimum SOP are there. How many minimum SOP expressions are there? Number of minimum SOP expression. Okay, so you can write your answer in the comments. So this is your homework question, homework number 1. You can pause the video and you can solve it, and you can write your solution in the comments. This is your answer also. If you see for this question, the answer is this. So you can pause the video and you can check it out, but my suggestion is that you solve this question on your own. Okay, so please try these questions, and whatever you understand, okay, so please try these questions, write your answer in the comments. And if you want to verify the correct answer, we will pin the correct answer will be pinned. Okay, so you can write your answer in the comment, and whatever will be the correct answer, one detailed correct answer, if you write the correct answer, okay, all these things if you write, number of prime implicant, number of essential prime implicant, number of minimum SOP expressions, all these things if you write, then we will pin it. Okay, it will be pinned. Okay, it will be pinned. So correct answer will be pinned on this video in comments. Okay, it will be pinned in comments. So you can try this question. If you want, for this question number 2, the answer is this. You can pause the video and you can check out this answer. This is the answer, but I suggest that you try on your by yourself. And this is your homework number 2. So these are the two questions. In this question you have to find number of, this is what you have to find. You have to find number of minimum POS expressions. This is what you have to find. How many POS expressions will be there? This is what you have to find. Okay, number of minimum POS expressions you have to find. How many minimum POS expressions you can create? This is what you have to find. This is your homework number 2. Okay, so that's it. That's enough. Okay, so thank you everyone. Thank you so much. Now the next standard session will be on Sunday. Okay, in the next standard session, what we will discuss some questions on adder and hazard. So this is the next standard session. The next standard session, that will be on Sunday. It will be on Sunday, and the topic will be hazards. Okay, we will take a lot of standard questions on hazard, static hazard. The topic will be static hazards. Okay, and the topic will be adders. Adders, full adder, carry look ahead adder, like okay, carry look ahead adder, ripple carry adder, full adder, half adder. Okay, so on these topics there will be questions. So next standard question session, so I will take a lot of standard questions. I will take on static hazard and also on adder. These concepts we have already seen. This concept we have already seen in the class, and this concept we will cover in the next 2 days, in the next 2-3 days. Okay, so the next 3 days we will cover this topic. The next 3 days we will cover this topic, and this topic we have already seen. This topic we have already covered in the class. So I know that you are very confident, okay, because you were giving back to back all the correct answer you were giving. Okay, so this topic, static hazard topic, we have already covered. So the concept I will not teach in this standard question session. In the next, on the Sunday, on the next standard question session, I will not teach the concept, but I will take a lot of standard questions on these topics. Okay, thank you everyone. Thank you so much. Okay, bye, good night.